All right, this is section 4-5, isosceles and equilateral triangles. So we're going to start off with a review of vocabulary. So we're going to underline the correct word to complete each sentence. So an equilateral triangle has 3 congruent sides. An equilateral triangle has acute angles. So we're going to circle the equilateral triangle. So which one has congruent sides and acute angles? This one. All right. We're going to add a word, isosceles. So isosceles are related, could talk about like equilateral or scalene. A triangle is isosceles if it has 2 congruent sides. So angles in the sides of isosceles triangles have special relationships. So here are some pictures. Isosceles, 2 congruent sides, 2 congruent sides. So use your vocabulary, use the triangles below, and write the letter of the triangle in this one. So A is a right triangle. So that one's done. And it's also isosceles. D is going to be an equilateral triangle. And notice it also has at least 2 sides congruent. So it's also isosceles. B looks to be just isosceles. C looks to be just right. And E looks to be just isosceles. All right, so the isosceles triangle theorem. If 2 sides of a triangle are congruent, then the opposite angles, the angles opposite those sides are also congruent. So if I know I have 2 sides congruent, then the base angles must be congruent. If 2 angles of a triangle are congruent, then the sides opposite must be. So going backwards must also be true. So the converse is true. And theorem 4.5, if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector. So if we have a line that bisects this angle, creates 2 congruent angles, we know it's the perpendicular bisector. Okay. So here we go. Number 5, if we know line segment PQ is congruent to line segment RQ in triangle PRQ, then angle P must be congruent to angle R. All right, we're going to use theorem 4.5 to prove we have congruent triangles here. All right, let's try this one. So is triangle WVS congruent to angle S? Is TR congruent to TS? Explain. So the markings show that line segment WV is congruent to line segment WS. Okay. Now, is WVS congruent to angle S? WVS congruent to angle S? Well, yeah, because isosceles base angles, right? So yes. Since WV is congruent to WS, angle WVS is congruent to angle S by the isosceles triangle theorem. All right, is angle R congruent to angle S? Well, look at this. I just proved S is congruent to this one, and this is marked to R. So I'm going to say yes. So yes. So angle R is congruent to angle WVS, and angle WVS is congruent to angle S. So angle R is congruent to angle S by the transitive property of congruence. All right, is TR congruent to TS? Well, I have base angles are congruent now, right? So this whole big one must be congruent to this one. So yes. And the reason here is since angle R is congruent to angle S, TR must be congruent to TS by the converse of the isosceles triangle theorem. Okay. All right, let's use some algebra now. So suppose we know angle A is equal to 27. What is the value of x? Okay, so since line segment CB is congruent to line segment AB, by the markings, we know it's isosceles. Since I know I have an isosceles triangle, I know measure of angle A must equal the measure of angle C. Base angles must be congruent, which, since they both must now equal 27. All right, notice how this bisects the angle. So since BT bisects the vertex angle of an isosceles triangle, BD must be perpendicular to AC. And that means angle BDC must be 90 degrees. So BDC is 90 degrees. But look at this, I know what the angle measures are. I think I can add them. So we know the measure of angle C plus BDC plus X must equal 180. Substituting in the measures I just found, I add those together, I subtract 117, and I get 63. Okay, to go along with the isosceles triangle theorem, we actually can show the same thing with equilateral triangles. So if a triangle is equilateral, then that means it's also equal angular. And if it's equal angular, it must be equilateral. So that's the same thing there, basically. Okay. So finding angle measures. So suppose the triangles at the right are isosceles triangles where angle ADE is congruent to angle DEC, which is congruent to ECD, and are not congruent, but they're vertex angles. If the vertex angles each have a measure of 58, what are measure of angle A and measure of angle CD? All right, so we're marked here. We know vertex angles. Okay, so this must be congruent to this. This must be congruent to this, and this must be congruent to this. Okay, so we have some ASA situations here. All three of these must be congruent triangles. Okay, so which triangles are congruent by side angle side, or ASA? Anything actually works in this one. So we have triangle ADE is congruent to triangle DEC, which is also congruent to triangle ECB. So then the base angles must be congruent, right? So which angles are congruent by isosceles triangle theorem? So angle A must be congruent to angle DEA, which is congruent to angle EDC, which is congruent to angle CEB, which is congruent to angle B. So we know by the triangle sum theorem, measure of angle A plus 58 plus DEA must equal 180 degrees. So two measures of angle A plus 58 equals 180 degrees. Two measures of angle A equals 122 when I subtract 58 from both sides. Divide by 2 and you get the measure of angle A equals 61. So since the measure of angle A is congruent to angle ECD, ECD must also equal 61. And then using the angle addition postulate again, measure of angle BCD equals 58 plus the measure of angle ECD, which equals 119. All right. And let's do a quick understanding here. What is the relationship between sides and angles for each type of triangle? An isosceles triangle has two congruent sides. An equilateral triangle has three congruent sides. The isosceles triangle theorem states that the angles opposite the congruent sides are congruent. Equilateral triangles are also isosceles triangles. And the sides and angles of an equilateral triangle are congruent. And that's it for this section.